Welcome to the Major Project Podcast, your inside look at the high-stakes world of billion-dollar projects.
Well, welcome to Major Project Podcast, hosted by me, Orion Matthews. We're diving into the world of high-stakes projects, each with budgets of over $1 billion, through conversations with industry experts, such as James Wiseman, who we have here today. We are uncovering key lessons, strategies, and insights to help elevate the practice of managing and delivering on these monumental projects. James, welcome to the podcast.
Hey, thanks, Orion. I'm glad to be here. Excited.
Yeah. And so, James, you've been a capital projects manager. You've got 25 years of experience in upstream energy business. I know you've led multiple teams through all the stages of major projects, I believe, from appraisal to startup. And you kind of have a deep understanding of both greenfield, brownfield projects. Maybe you can talk a little bit about your history. I know you've worked at Chevron. We worked together at Santos and Tesla and things like that. So maybe just take us a little bit through some of your career.
Sure thing, Ryan. Thanks. I like to say I work on energy projects. You know, I've worked on energy projects my whole career. It's the kind of thing that gets me out of bed in the morning, you know, especially the opportunity to do big things, which is really cool. But believe it or not, you know, I started doing decommissioning projects for 3 years.
Oh, wow.
And so I got a little bit of the end of life kind of stuff early in my career. But then after that, I kind of pivoted into deepwater projects, mostly like subsea, deepwater, the capital project side there. And then I also did a stint in a new ventures and exploration group at Noble Energy. After I finished a few projects, I got an opportunity to do that. So I got to see kind of like the drivers of what makes a good energy lease and like how to get into them. That was pretty cool. And like figuring out different ways to do projects to make them economic. And then, yeah, I've done the Arctic stuff up here with Oil Search and Santos, dipped my foot into renewables a little bit. I did big project for Tesla, the like integration of all the teams for their lithium refinery down in Texas. Was down there in 2023 and 2024. And then did a little bit of renewable energy consulting. And now I'm back in Alaska working for the Alyeska Pipeline company.
Awesome.
I've been all over the place. Lucky to be able to work in some crazy places like, you know, West Africa, Russia, Alaska, obviously. Texas is a little bit crazy offshore. So it's been a lot of fun. And doing these big projects is really, really exciting.
Well, I'm really excited to get into them with you. And I think this kind of brings us to our topic, which couldn't be more perfect to kind of talk about, which is energy and people. Like, how do we, you know, grow and use the people and skills we have and keep the big projects under control, you know, to deliver on this almost exponential energy demand that is here and is coming. Very excited to talk about that. And I think when we were listing out a couple questions, one of the ones that was really fascinating to me personally was to talk about scale, because energy scaling up and projects that are as big as the ones you've worked on in the $1 billion space. And there's so few people that have actually done this. It's so unique to have you on and be able to talk about it. But how do you scale fast? And how do you do that? How do you do it right in industrial engineering and construction and all of these major projects, would you say?
Well, you know, that the oil and gas like project execution approach is very well structured. Over the last like 20, 25 years, there's this like stage gate approach that's been developed. You know, you just follow these steps and your project is going to go great, right? And like, it's just not the case, because projects are planned and built by people. You know, there have been a lot of learnings along the way. The getting a project over the line is really, really hard. You know, some of the people that we know, they call it like riding the bull. And, you know, you're trying to stay on the bull and keep the project on track for 8 seconds, right? Is riding a bull. Yeah. And like people fall off all the time. And people always ask, like, why did you fall off the bull? You know, like 8 seconds, it's not that long. Can't you get this done? And it's just tremendously hard. You know, it's like balancing on top of a ball. And, you know, to get a project done, you have to have the right plan You have to have and you have to have the right people. And if you don't have that mixture, it's really, really difficult. And obviously both of those things combine to make like the project culture for a good project. So that's kind of the macro view.
And then once you get those things set up, how do you go fast? Because as we're sort of seeing, I think the stat is that 5,000 data centers are going to be built over the next 5 years. Maybe that's a little high, but somewhere in that neighborhood. And so we're entering into this period where it seems like more and more major projects are going to get executed in a rapid period of time, and they need to be built quickly. And what advice would you give somebody that is sitting in a boardroom or maybe in a leadership circle and thinking about building a $5 million major construction project, and they want to do it as quick as possible?
The joke I think we talked about once is there's no like big red easy button that you can push that says do project, execute project. Yeah. And so like the mega projects take a long time to get all the permits, get all the financing and money together, and then like sanction the project. And so a lot of people think once you get the money, you just push the button and you just go. Yeah. But it's very difficult. Like you said, scaling is really tough. The energy business needs to have some kind of breakthrough in order to do all the projects that we want to do right now. It's a very strange time where you have like kind of the traditional oil companies shedding people right now. And then you've got the other companies that are just desperate for people. And like, if you look at the number of LNG liquefaction plants that are sanctioned right now or in feed, and how many are going to be built in the next 5 years, like there just aren't enough people. And that's not counting the data center stuff that you mentioned, Orion. So it's just a very interesting time. The traditional ways of working, like we talked about with the stage gate, they are very clunky for what the kind of like the new energy business wants to do. If you look at like traditionally, you plan, you come up with a scope, you like engineer that whole thing into a big package, then you buy some materials, and then you hire contractors, and then you go do the project, right? So like that is not the way people want to operate now. Certainly not Tesla. It's like the execution approach is more like, what can we buy now and what can we do now so that we can keep things moving fast?
Yeah.
So like Tesla, for example, on the lithium refinery, once they knew they were going to do the project, it was like not a question of like, oh, there's 16 different ways to do this. Like if we just improve this one a little bit, we'll get 1% more rate of return. So let's work on it a little more. It was like, no, we are going full speed ahead. So those old like kind of stage gates need to just be broken down. And so like the new way of executing now is like, what can we do and what can we buy to accelerate the project?
So a lot of pre-feed kind of activity, but also just blurring of the lines between where you're at when you think about a stage gate, in a sense.
Yes, definitely blurring the gates. I just think of it as a stream of activities now. As long as you know you have a good project, you just go as fast as you can. And so it's not necessarily the engineering phase is not necessarily to deliver the best, like 100% design detailed package. It's like needs to be sequenced to order materials and keep the materials flowing into the project.
So this is a little bit in my world of software development, right? We had this transformation where everything was waterfall, which is essentially somewhat of a stage gate approach to building software solutions. And then Amazon and some of the other really big players came along and they had this same problem of like, we have to build Amazon.com and it's a multi-billion-dollar investment, but we're moving really fast. We just have to get it done. And they kind of invented Scrum or agile methodologies which essentially just says, we'll just keep paying money and keep this team together and sort of manage all these sort of dots on the board as best we can and just go forward. And that methodology, I was really skeptical of at the time. I'm a little bit older in the software business. And I was like, I don't think that works very well, but it's worked great for them. It takes a leap of faith, I think, in terms of cost control, because when you don't have everything defined and you're just like, we're going to order this stuff, let's just do it. It's hard to give a final number, right? It's maybe more of a range. Like, how do you think the energy business might do you think they'll accept a model like that? Like how would you explain it to people?
That is a good question because I think the bigger and slower, like traditional oil companies, are struggling with how to do this right now. If you look at like the oil companies themselves, they decided maybe 5 years ago, like maybe a little bit earlier than that, like we want to do renewables. Like BP is going to be doing a lot of renewables. They all opened a new business and they said they were going to do this. But like they tried to do renewable energy projects like oil and gas projects. And
Mm-hmm.
like, who's going to hire an oil company and give them money to do a project that old fashioned way? It's just like not gelling. I don't know if you've seen, but like, it's just not working for them. So like, as an investor, who would I want to give my money to build a data center? I wouldn't want to hire a midstream energy company that runs pipelines. I wouldn't want to hire an oil company. Maybe I don't know who I'd want to hire. Right now,
Yeah.
there's a lot of financial hucksters out there that are basically like, just give me money and I'll get some gas turbines and I'll build you a power plant. So it's a really interesting time. And I don't think there's any like best practice yet.
Yeah.
I think like Tesla is very good at being first. And the prize in the things they're chasing and some of the data center people are chasing, the prize is so big to be the first mover that like it really isn't as important to like have a perfectly cost controlled project as it is to be first. Right.
Yeah.
And LNG might be like that too. If you get to ship the first cargo out the West Coast, like the Canadians got to do that recently, like LNG Canada or the people in Mexico, there may be some huge value there that it's not like captured in your like metrics, are very difficult to capture. So like, how do you scale? You just need to have good plans and good people is my first principles for that.
Yeah.
Internal
Well,
bliss.
and I think you're tapping on the door of something that really, it's almost a crisis, if you could say it that way. I mean, it sounds alarmist, but it's like there's a transformation that needs to happen in the space around thinking about how projects should be executed almost at a fundamental level, like Scrum to versus waterfall, and sort of breaking down those barriers is going to be a must to meet the energy demand, which maybe we can tiptoe into, because I'm really excited to talk about some of the sort of things that are happening around there, particularly renewable energy. I know that you have some experience and understand the dynamics of what's going on with lithium right now. I know Chevron, I think, announced that they're going into lithium. So I'm kind of curious what you're seeing on the world stage in the energy space, and particularly in the renewable energy space.
You bet, Orion. Yeah, I'm super passionate about this. And it's not because I'm like an evangelist of renewable energy. It's that we need so much more electricity right now. And we're like a cave diver and we've gone all the way into the cave. And like we might not have enough air to make it back out again.
Right.
Like
Oh,
like I'm an electric ratepayer and I know you are. We're all using electricity right now to do this podcast. And like people need more electricity. And if as ratepayers, if our electric bills start going up because of these data centers, et cetera, people are going to be pissed.
yeah.
So like we have to find a way to get the energy that we need to do this. And it's going to be tough, If you just look at renewable energy, it's like, it's sort of intermittent, you've got many different ways to make it. I think like the ones that I'm interested in talking about is obviously like solar and battery storage. Like we'll hit that one first.
Mm-hmm.
Geothermal, enhanced geothermal. It's super hot right now. That was a good pun. We'll talk about that a little bit, and then just keep going with natural gas because we have a lot of it, and it's actually, I mean, I don't know if you saw the news last week, the UN still considers it like a low carbon, or I don't know if they called it a renewable, but they call it kind of a green fuel.
Yeah.
Anytime natural gas displaces coal for making electricity, it's a good thing. So, let me just kind of work my way through those.
Mm-hmm.
And you're right that the majors are starting to explore and get into like producing lithium. They're making joint ventures. Exxon, I think, was one of the first to do a big one here in the States in Texas and Arkansas. And then I think Equinor went in next when they both went with local partners. And then Chevron just announced they're going in last week. And oddly enough, some of our friends from Noble Energy are like heading that up. Like Kristen Gaddis, I used to work with at Noble, is heading that up at Chevron. So it's a very small world in the energy business and very cool. But like if you just focus on solar, it's like really simple. Probably some of the people of listening to this have solar panels on their house. It's kind of cool, right? Like when the sun's out and it's really hot and you need to run your air conditioner, it's great if you can run it off the solar, right? So that's kind of cool. Or if you can charge your car if it's in the right place. But like if you look at like the output, you really only get about 8 hours a day of like really nice energy production. And electricity has to be 24 hours, 7 days a week. So like 2/3 of the time, you've got to do something else. So like with solar, you have to produce 3 times the energy you need in an 8 hour period so that you can go for 24 hours. And that'll just get you to the next day, you know?
Yeah.
So the storage component is a really big deal right now. And that's where, you know, energy storage, there's a lot of different ways to store electricity. None of them are like super awesome yet. You know, you can convert it to hydrogen and then you can have a fuel cell. You can put it into like some kind of chemical storage, which is batteries and lithium iron phosphate's really pretty good right now. And then you have to be able to, you have to like produce enough electricity out of your batteries to get you kind of to nighttime when things tend to settle down and there's more electricity available. So that's kind of what batteries are doing right now. But eventually we need to like figure out the fact that like you have to produce 3 times what you need during the day.
Yeah.
And then you have to store it and have it ready when you need it. And then we have to figure out long duration energy storage, which we like barely scratched the surface on that one. So go ahead.
So I'm just curious about that. Like, how do you think the industry do you see a connection between battery technology then and solar is basically the answer to that problem? Or is it more like battery solar is great, but you're going to need a bridge with natural gas or some other, it's going to be a mix of energy effectively to solve this problem?
We need everything on the list, right?
Yeah.
It's totally true that we need all of the above. So like the battery storage and solar, it's getting to be like consumer level now where, you know, people have batteries in their garage and they have solar panels on their roof and they're kind of getting comfortable with it. So that's why I kind of hit that one first. But there's a lot of other things. I mean, you've got intermittent stuff like wind and sun, and then you've got base load, which you just have to have. You just have to have that steady, like producing electricity 24/7. And, you know, nuclear does that. Geothermal energy can do that. You know, natural gas combined cycle does that pretty well. Like you need the mix. So that's what I'm getting at. Like we definitely need everything all at the same time. Because if you look at electricity demand curves and things, we just need everything.
Yeah. And so when you talk about building like a solar project, like at scale, like $1 billion renewable energy project, because you've worked both in that space and then you've worked on traditional oil and gas, are there differences that, say you're somebody that's been in the traditional oil and gas space and you're about to take on a big multi-billion-dollar solar farm project? Like, do you have advice for someone that might be going into that, or some thoughts on how those projects should be executed or even planned or defined?
Sure thing. So they're very different, as you can imagine, right? I mean, if you just look at a solar farm and use that as an example, it's kind of like an oil and gas unconventional project in that you've got to get good land with good sun and good place to build a solar farm. And then you have to do like very efficient design and installation of solar panels and electrical cabling and inverters. So instead of drilling and completing, you know, 16 wells with hundreds of frac stages each, you've got to get like really good at like planning and installing thousands of solar panels. So it actually has some parallels, but it's a very like utility scale solar is like a very commoditized thing now. You know, people know like kind of down to the penny how much everything's going to cost per kilowatt hour, but that's just for producing electricity for that 8 hours. You know, the storing it thing is just starting to ramp up as a big business now. So like there are a lot of parallels between like unconventional oil development or gas development and like utility scale solar PV. But like I would say the battery storage is kind of like the Wild West. People have been going out there, just kind of like landmen, trying to buy
Yeah.
land near electrical substations. Pretty much all bought up now.
Right.
And so they can put battery storage there so they can like either feed it to the grid or take it off the grid. So there's a very like intense commercial component that like the major project people don't often see that part of it. They're like, why are we building this here? You know,
So, and if you have like a project team that's delivering on that, so if I'm making the translation here from old world to new, or I guess different world to different, you have a drilling and wells team, and they were always sort of like could have been considered one of the stars of the show, depending on what kind of project you're involved in. And they're out there getting those wells done. For a solar farm, is it the electrician team at that point that they're like the workhorse team that is putting together those wires, and or is there not? Yeah, I'm just kind of curious, like how you divide up the groups there.
You know, like the traditional stuff sort of goes out the window. I think like the people that have the hardest time right now are the supply chain and procurement people. Like getting the materials for the inverters and cabling and the solar PV and all that, probably incredibly hard right now.
Really?
Just due to the changing commodity environment and trade. But like, I would say maybe the other thing is just like anything having to do with electrical grid connections, high voltage is extremely high demand and long lead time. Whether it's getting like a intertie or a grid tie done, that could take like 5 or 6 years to get all the way through where you can actually kind of like close the switch. Incredibly long. And then finding like engineers that can do high voltage electrical is pretty tight market right now.
Okay, question real quick. And I know we got to jump. We got to talk about geothermal soon, but I really want to know, like, I've heard this before, that procurement is the bottleneck. Why? We're in a digital world now. We all have digital supply chains. How could procurement be? You would think that's, I guess, the intersection of supply and demand, right? It's kind of like the ultimate expression of the capitalistic model. What do you think is the difficulty on procurement, or what do you think is going on?
Just for solar, for example, or let's just say any electrical components right now, Orion, like transformers. It's just like demand is outstripping supply on so many of those things.
Huh.
And then if somebody puts a 25% tariff on you or you put it on them,
right.
Like just imagine the project economic impact if you're ordering, 5,000 solar PV module panels. So like, it's just tough to plan around that like the companies that aren't getting tariffed, everybody wants to buy from them. So their lead time just went through the roof. It's very unpredictable. And as you know, like to plan and execute, you want predictability.
And it's also like some of the things I know with NVIDIA, for example, and the factories that are producing chips, like they have huge demand, but in order to actually build a factory to do fabrication of chips at the level of precision that we need, which is probably similar to transformers, it's just not something you can throw up super quick. And so, yeah, that supply and demand, maybe it will level out, but it's going to be a while, it seems like.
Yeah, it's just the market likes certainty on things like that. And it's just hard to plan with a lot of uncertainty right now.
Particularly on a mega project, because it seems like it's almost always an international effort to do these projects. Yeah.
Yep. And like Tesla Megapacks, they're large battery storage modules. They're like the tractor trailer size, 1.3 megawatt hours ish. Those things, like when the administration changed, those things went in high demand. And like, if you didn't have your order placed, it was pretty tough. It was pretty tough there. So that's kind of one example.
Yeah. Well, let's shift over and talk a little bit about geothermal then, just going back down that list. I think that one was next. I'm excited to crack into this a little bit, to use another pun.
Yeah. So I am not a geothermal expert by any means. I'm just interested in it, and I've researched it a lot because it has all of the makings for a really good energy system for us. And it uses a lot of the skills that we've developed in this country over the last 50 years in the oil business, and especially in the last 15 in the unconventional oil business, right? So it's like, and it's base load energy, right? You've got hot rocks, you're converting that through all kinds of different systems to make electricity, right? That's the core of it. Dang, I just made another ton. So the thing that's cool about this is, and it's just really started to pick up the last couple of years, is enhanced geothermal energy. You're not pulling like hot water out of the ground that's already there.
Mm-hmm.
Like, there's a big project out in California in Calistoga. It was producing all through until about 2000. There's already water and there's volcanism, there's hot steam, and like the people, Unical was one of the companies, drilled down, produced that steam, made electricity, right? So like enhanced geothermal is not that. It's like finding the right rocks that are hot and can conduct the heat, and then drilling, instead of drilling like unconventional oil, you still drill two wells and you fracture, but you use it so that you can like inject water down one well, pump it through the rock, through the fractures that you've made, turn it into steam, high energy, and bring it up the other well. So that's like enhanced geothermal in a nutshell. And like, if you want to learn more about it, Fervo Energy in Houston, like they've attracted a bunch of interest, a bunch of capital. They're doing some really cool projects. You can read more about it on their site. And that's kind of like enhanced geothermal. But what's so cool about it, yeah, it runs 24/7. It's always producing electricity. And it uses like these drilling and completion techniques that we've learned in the oil business. If you think like, what is the coolest renewable energy mix right now? It's one that's like close to oil and gas, but produces energy without like producing CO2.
Yeah.
It's like, it's got all the ingredients. So I think it's really going to take off. And, if you look at the different parts of the country, the places where people need electricity, I'm sure you've heard of like the Pacific Rim and Ring of Fire. A
Mm-hmm.
lot of people in that area that live in the Pacific Rim, and there's a lot of geothermal heat there. So nice, if you look at it that way, but other places have it too. It's just even in the Permian, believe it or not, I think is pretty darn hot when you get
Yeah.
down. So,
How hot do you have to get, really? Is it enough to make steam, or do
well,
you
you have to
just
get much hotter than boiling water. You have to
okay?
get much, much hotter, like kind of like a good number for like steam in a steam power plant's like around 700 degrees Fahrenheit. And
Okay.
like, if you look at like drilling and completion equipment and tools from the oil field, and it's just not there for that kind of temperature use yet.
Yeah.
And the kind of rock that you have to drill through is much different.
So are there like reservoir engineering kind of specialists that can find these hotspots too, or is it a new field of study and people are going out there and taking a look at all these old pieces of land, or like how do you find these spots?
I think it's a little bit of both, right? It's like
Yeah.
you need to find the hot rocks that you can fracture. And so instead of looking for like looking for oil, that and like running some economic models on how much you'll be able to produce and what costs, this is more about like how much heat and heat flow and how much the equipment and drilling will cost to do it. So I think it really ports over a lot of the people from the oil field.
Yeah. And I guess that ties into something that we sort of started the conversation with, which we eventually will have to tip into, which is talking about that the oil business is shedding jobs, or has been. Maybe that's reversing. And these are really great things to talk about these areas that people can go. Maybe you're a drilling engineer and you're out of a job. I didn't know anything about what you were talking about with fracking. So that's a pretty great option, that something is going in for creating geothermal energy. That could be a really interesting career path that aligns with those kinds of skills.
Oh
So
yeah, definitely.
yeah. And I guess what would be your advice if someone wants to get into the energy space and maybe make some of those bridges?
The energy business is a great business to get into. Even the oil and gas business is still incredibly challenging and fun, but now there are a lot of other segments of the energy sector that you can get into also. So it's good. It is a really good place. And I think like my like 10,000 foot level is, if you don't know what you want to do when you grow up, but you like science and math, if you want to go to college, become an electrical engineer. And if you
Mm-hmm.
don't want to go to college, become an electrician. Like we need those people so badly in this country. The world needs them. And if
Yeah.
you look at kind of just the demand for electricity and everything that we want to do, you can understand why. So that's my kind of my first advice. If you're like looking to get into the energy business, there's so many different opportunities. Like, how do you decide what part of it you want to go into? And you need to go to meet some people and go to career fairs. You need to go to like the offshore technology conference. You need to go to the like renewable energy conference. Like here in Alaska, we even have a local energy conference focused on renewables, and it's every year in April or May. And that is a fantastic conference. I've been to that one. Just the best way to like decide like what do you want to do when you grow up in the energy business is just to talk to people that are doing it. And there's so many areas now. There's the emerging stuff in renewable energy, and like there's probably some things that haven't been invented yet too.
Yeah. AI is somehow going to work its way into this, which might be another interesting topic to see if you feel like that. I know that AI is impacting energy demands substantially. I think, what do they say? Bots for watts for bots. Is that right?
I haven't heard that one before, Ryan.
Yeah, people are I think originally it was watts per person is the way that you look at energy, and now they're saying it's watts for bots, which
That's
is
nuts for a
driving
GPU
demand
box.
as well.
Yeah,
Yeah.
that is nuts. Yeah, it is a lot of electricity, and yeah, like we talked about earlier, people are going to be really pissed off if their electric bills start going up, so that they can ask, how to make scrambled eggs or something like that, and AI will help them.
Yeah.
I
Well,
don't know what we're going to do.
what kind of speaking of that, because you're at the high level major project craft, have you seen any impacts? Obviously AI is impacting demand. Have you seen any AI impacts start to wiggle their way into the major project space yet? Maybe in terms of how people are executing or using it as a tool or using it to learn. There's a lot of conversations going on about it, but I'm curious if you have any thoughts about how it might impact the space or is already.
Well, I think it's certainly helping with analyzing performance on a major project, right? There's, like you talked about earlier, there's thousands of people building some of these billion-dollar projects, and they're all
Yeah.
over the world. They're fabricating in Asia and transporting and building and installing here. And so it's definitely, people are working on, I think you guys might be working on some way to analyze project and performance and control it with AI, because finding the needle in the haystack of what's going wrong on a project is very difficult. Finding the important data can be tough.
Yeah.
So especially when you can't like be everywhere at all the time talking to people and like kind of getting the real gist of how things are going.
Yeah.
So I see a lot of room for it to help us there. And I'm not really sure. When I was at Tesla, we were working on the piping for the lithium refinery, and Drew Baglino asked us like, why isn't there a software that can just automatically route and design all this pipe for us?
Yeah.
And it was like it, and I was asking myself the same question, like, how can it be this hard that we can't, we had, I don't remember how many linear feet of pipe to route, but it was a lot, right?
Mhm.
And it was like, why are people like clicking, from pipe support to route pipe these days? So, there's probably something going to happen there,
Mhm.
for sure, when it comes to automating some of the design, and that's a little bit scary for some people. And it's also really cool.
Yeah.
So those are just a few I could think of off the top of my head.
Yeah. And do you think, I know that you have a lot of experience as well in modular fabrication. Is that right? And I wonder if maybe modular fabrication and AI will both be impacting the space at the same time, because that's kind of a model where AI is like, here's how you route everything. And then modular fabrication also kind of simplifies these major projects into sort of bite-sized chunks. Is that kind of the way that works, kind of help you scale up and sort of compartmentalize your problem and simplify it?
Yeah, I mean, you've hit on a couple important things there, Ryan. One is that like improvement in construction efficiency over the last, like, say, just pick 50 years, it's not improved a lot.
Mm-hmm.
And so, like, turning construction into manufacturing is one. Manufacturing has improved dramatically, right? On how fast something can be built. So like that's what one of the things about modularization that's cool is like turning part of the project into manufacturing. And the other thing is like you don't necessarily have the people where you need to construct the project, right? Like offshore, we talked about modules, right? You lift a 10,000 ton module onto an offshore facility, building platform. So like you build it one place, you bring it there, you put it onto the platform, right? Because you can't get the people there. So that's another area and reason that modularization is so cool. You kind of can break like, or if you're building it somewhere and bringing it somewhere where you can hook it up, you just have to find kind of like the right mix of skills. You want like I don't know, just kind of some like typical modules. You might have like a gas compression module, electrical power generation module, living quarters module. You want to get like the right skills to build a living quarters module where people live and eat and sleep. So that's very different than the people that build like the power generation module. Right. So, you want to find the skills there. And I haven't really thought too much about how AI would help with that. But, what it can help us with is like, how can we change construction more into manufacturing?
Yeah, that's a really interesting insight that I hadn't thought about. That particularly the fact that we haven't really made a lot of progress, and other industries are sort of making these exponential leaps. So kind of time to take a few new approaches. I think with modular construction as well, I mean, how would you advise someone that's listening to this podcast? Let's just pretend they are working on thinking about executing a major project. Maybe they're in the planning stages and they're like, wow, modular is a pretty good idea, but I haven't really thought about doing that before. Is it too late? When's the right time, would you say, to take that? Is it like, it's an execution strategy, right? Like can you shift to it, or do you want to do it at a certain point in your project, I guess?
Yeah, and it's definitely, remember how I said like you have to have the right plan and you have to have the right people? Yeah. So like this is definitely the planning phase when you decide this. And like, there's the term stick built. That's where you build everything on site. You just bring it there and build it. And then modularization is kind of the other end of the extreme. Like in a perfect modular project, you just bring it there and set it down, hook up your power and your outputs and things, and you start it up. So it's definitely in the planning phase. You need to decide. And it's going to be based on where you're working, where the talent is, and how kind of like how remote you are, and if the capacity is there. I mean, modularization isn't going to help you if every yard that builds modules is chock-a-block full building LNG plants.
That's true. So it goes back to procurement in some way as well. You have to make sure you can find someone that can do it.
Yeah, and it's not like a solution for everything too, Orion. As you can imagine, the difficulty with modular fabrication is getting the module finished and like pre-commissioned and maybe partly commissioned before it comes to your project site. And like a lot of times it's like you have to ship a module before it's done. You got seasonal constraints, you've got a permit requirement, governmental rules. If you have to start, sometimes you have to ship the module when it's not ready yet. Those are the challenges, is getting them done before they ship out.
Well, and is that, I guess, if I were to try and make a case then for doing this, let's say it is the right setup, is there like the Modular Construction Association of America that will sell you a book on this? Or like, how do you build out that case to leadership that might have never done a modular project? And I think you may have actually helped encourage groups to do some modular work in the past that hadn't done it before. I'm curious if, how you go about like helping people understand the value and get a project to shift to a modular focus if it needs it.
If you look at like, just pick a nameplate of something. Let me use oil and gas because I'm used to that. You want to produce 60,000 barrels per day of oil, right? Mm-hmm. And so you're going to need, say, 20 big modules to do it, or on an offshore facility, maybe 3 super mega modules. So like you look at the cost, and you look at how much faster you can do it. And there's usually an immediate value addition there. right?
Mm-hmm.
Where it might be a problem is if you need to use local labor. Some places like, okay, great, you're going to build all of your modules overseas, bring them here, and there's going to be like 5 jobs to hook them up, like
Right.
5 full-time people. So, that's an extreme example, but you really want to look at that, like, before you decide, like, maybe part of the project is modular and part of it isn't, because there's some intrinsic value, inherent value in having the local people,
Yeah.
involved and invested in the success of the project too. So, but usually the value is pretty obvious. There are some downsides. Just if you think about having to lift up a giant heavy steel structure, you have to put a lot of structural steel into a module that you
Mm-hmm.
wouldn't need if you're just building it in place. So
Okay.
there's
Yeah.
extra steel weight in there, but people kind of tend to think of structural steel as not that expensive, especially in like a high tech fab. So it's probably okay.
Thank you.
Does that answer your question?
It does. And I think this is a good time to segue because we've talked a lot about energy, and the topic was people and energy. And one of the things that I remember about you, James, we were in a meeting. You're the first person I've ever had on that actually was I was able to work with and so I got to be under your leadership a little bit, and it was really great. And I appreciated it. And I remember we were in a meeting. I don't really remember what was going on, but it's something, and you were able to come in and you set the tone. You de-escalated a crisis and said sort of, hey, let's wait a second, let's just pause and make sure we don't, this isn't, you paid attention to the people, and you thought a lot about, I think, just sort of the trade-offs, and wanted to make sure everyone was okay, and that we took the time to do it right. I think it was a good call at the time. And I just remember thinking, like, James is really savvy as a culture setter and as sort of a leader. And now that I have you on the podcast, I kind of ask you what kind of advice you would have for people, or how to kind of run teams. And I don't work within your space anymore, so I'm not even plugging you as a boss, but like I guess, like, what kind of strategies and techniques have been helpful for you to develop your leadership style, and what advice do you have for people that want to be successful in leading these mega scale projects?
Right on. No, that's a great question. Thank you. I like to think that I've got some skill in this area, Orion, and I'm glad to hear from somebody else. Engineers aren't always viewed as the most empathetic people. And it's like dollars and cents, it's like solutions and math. But projects are built by people, 100%. They don't build themselves,
Yeah.
you really have to look at it as a team. And I don't believe in the like traditional command and control leadership style is like going forward as a great way to work. I don't think people like working in a team like that. And nowadays people have lots of choices about where they want to work. And so people want to be a valuable member of a team. So like the project manager is almost like a coach at this point, or project director.
Mm-hmm.
If you've got a really good team, you're just helping them like drive toward the goal line. And so seeing how people work and finding out how they communicate. I always do that with people when I set up a team and meet with them for the first time. Hey, if something is going wrong, do you want me to text you, call you, email you? Like, when's a good time? If you're not available, just tell me, like, I'll call you in 10 minutes. Just going through that with everybody and realizing that, like, it goes both ways is very important. You want to communicate the way people like to communicate. Some people like an email where they can summarize everything, all their thoughts in one spot. Some people are just text me, hey, call me.
Yeah.
So that's a big part of it. Looking at yourself as a coach and letting your people do their thing is really important. People hate to be micromanaged. The thing is, in major projects, though, like you do have to be controlling the project and moving it forward. So it's not to say that you can't control, because you absolutely have to, but it's really about like helping the team see the milestones that are coming up and like getting everything lined up to hit those. So if you help people get those things lined out, you have a good plan, and people have the tools to execute, then you can kind of just let them rip. And I mean, that is the best team to be on, is where everybody's, and then people just look to you as the leader to help them if they get stuck. That's kind of the way I look at it. Definitely a lot more asking these days than telling, in the major project world. That's like really, really important. And just recognizing, people want to always be learning on the job. So major projects take a long time. Just getting the project like through the planning and funded and to execute takes a couple of years. And then executing a major project can take 2 to 5 years maybe. So, people need areas to grow on the team, move around and like find new challenges. I mean, there are just very few people that are coming into the workforce that want to do the same thing for 5 years. Can you imagine?
Yeah.
So, having the, so as you go through the different phases of the project, people can move around to what they're interested in or what they're good at, and want to do more of. So I really encourage that. I mean, those are just some of the things I do. And always remaining optimistic. I mean, I'm sure you've seen that about me as well.
Yeah.
People would never do projects if they weren't optimists, because there's so many things to overcome, to get one of these mega projects delivered. And so, I'm always optimistic about getting the project done, because I know, when people work together as a team, there's really nothing they can't do. And so just keeping that level of optimism is super important.
And it's engineers, like you started with your comment, oftentimes have a hard time with that style, I think. And again, from the development world that I'm in, we run into that a lot, where people are a math equation and we're going to solve it. And then we're going to factor that math equation and get rid of a few people. And then it's still going to work. And like somehow something about that doesn't quite work all the time. Have you any advice to someone that might be listening to this and they're like, yeah, that's kind of true. I'm an engineer. I kind of just sort of see it as like moving people from A to B, but maybe I should try to soften, maybe become a little more Wiseman in my approach. How would you advise them to kind of learn that style? Is there some books that you might have read, or ways to kind of adapt? Because I think there's more people that are in the rigid. When you come through the hard sciences, it's often a transition to that sort of management style.
I would be hard pressed. I think a lot of these things are very difficult to learn by reading a book, and they're very easy to learn by doing. So like my first thing that I would recommend is I'm not like slagging on any books. I'm just saying is to ask a lot of questions, right? As you're going into this, the best way to learn how to get a successful project for everyone is just to ask a lot of questions. Find it, and that's how you find out what's important to everyone. So that's kind of number one. And number two is that a lot of times the best technical solution is not the best overall solution. So you've got this whole new arena of stakeholder management, where if you successfully complete a project and meet all your targets, but the stakeholders, the people that are going to be interacting with or using your project or benefiting from it, if they're not happy, then you may not be successful. So this whole thing of finding out some technical solutions and then just talking to the people that are going to be involved. Just to use a tight example, it's the operations team, the commissioning team, the communications and local affairs people. Hey, here's some different options that we're working through. What are the pros and cons, right? Just asking those questions will really take you far. It's tough to learn a lot of these things from a book. You really have to try them out on a smaller scale and just learn as you go. I mean, there are a lot of good books about major projects, and they talk through how big things get done is kind of a cool book. Talks through a lot of project failures and why they failed, and talks through some of the prototyping you can do and how to plan. But it's great. You really have to practice. You really have to just practice to do it.
Well, and I guess I want to touch on one thing that you sort of triggered in that description, which is that projects, and we talked about this with modularization, but projects are executed by people, and then people in the community that those projects exist live with the results of that project. They are integrated into it, into the fabric of their lives, possibly for a really long time. I'm just curious about, like, as you were talking about, like, these projects have to work for you. It seems like the stakeholder management and the, like, being in connection with the communities that you're going to impact and hopefully have a good outcome for them is like a new, not new, but it's always been important. Maybe it's more important today than ever before, as the world's sort of getting smaller and people are able to communicate across all different types of communities, and so that the impact of these projects has to be sort of woven into the community and thought through in a more deliberate way. Maybe, do you think that's the case these days?
Well, if you look at like a perfect outcome, or what might be a perfect outcome, say for like a electricity projects, say on the West Coast somewhere, you want people at the end of the project, when the thing is started up, you want everybody around there, either that's worked on the project, that's benefiting from it, that lives nearby, you want them to be proud of that thing that you did, right?
Yeah.
Like that is your hallmark of success, right? Is like, wow, I've got a steady job working at this facility now, 7 days a week, 12 hours a day, I'm working there. Or like, yeah, we're producing this thing and exporting it, and we're like increasing the GDP of our country. So there's like getting that pride in project is very important. It's another thing that helps with the stakeholders.
Yeah, that's really cool. So speaking of stakeholders and people and the energy business, would you say that, as we talked about this, we said oil and gas is shedding, geothermal, solar, wind, nuclear is on the rise. Is that a fair thing to say at this point? Or perhaps like it's balancing out? And I'm curious, like, as you're managing these different people, do you have any advice for how to sort of bring someone from one space to the next, how to level them up and make them feel comfortable on a team? Maybe if you're joining a team of engineers that have been in the oil and gas space a really long time, how do they bring in someone from the solar side? Like, how do we keep this community together and grow together rather than being so siloed?
Just first though, I don't know what's going to happen in the oil and gas. I don't know. They are shedding jobs right now. You can read about it in the newspaper, but like, it's a very strange time. Like there's plenty of oil and gas right now, but there's not plenty of electricity, and there's not this like growth and exploration happening where like we know where the oil is going to come from in 5 years. We don't know right now. It's really weird. So I'm just not sure what's going to happen there. But like, as far as putting together a team with a mix of these folks, that is really interesting. Coming into like, say, Tesla, when we were building the lithium refinery, it was really fascinating. We had people that had recently built like the battery module factory in Sparks, Nevada. We had people that had been working as operators in a chemical plant for Exxon in West Texas or East Texas. We had people like me from the upstream business, and a lot of construction management. So it was an interesting mix. I see like the key to success there and coming in is just being willing to learn how the other people do things. I had a very like fixed in my mind way of doing things, and I started to like listen to everyone at the lithium refinery project, and I realized we're not like making high pressure flammable fluids out of this project. We're making lithium hydroxide, and so like, okay, so the stakes weren't quite as high. Nothing was going to blow up. So that was kind of like something I learned by talking to everybody.
Let's shift over and talk a little bit about the job market. We've been hinting that the oil and gas space is shedding jobs, but it's really not just the oil and gas space. Kind of everywhere there's a lot of transition happening in the workplace. Some might be AI related, it might be tariff related, the economy shifting, things like that. I guess just maybe giving some of the younger listeners that might be in college some tips about this energy space, which we also said needs a lot of jobs. So maybe there's some advice that you could give our younger listeners that are looking to go into this field.
Right on. If you've seen some of the comics, like there's a lot of jokes. It's like, oh, so, the doctor's like got the baby and he's like explaining to the parents, I got some bad news. Like your son or your daughter's an engineer. And that one always cracked me up. But like, no, engineers are problem solvers. And there are so many problems facing the humans and the planet right now. And like having enough energy is one of them, but there are so many other ones, just like developing things to help people live longer and be healthy, have clean water and clean air to breathe, get to the places they need to be, right? So there's just so many fun things to work on. If you don't know what you want to do, but you like solving technical problems, there's so many opportunities out there. And so the best thing to do is like talk to people that are solving these problems. As a early career person, or if you're in college, there are so many events that are like pre-made just for you to go and kind of get a flavor of all of these different areas. Oh, I think wastewater treatment is really interesting, or I think building semiconductors is really interesting, or I think drilling for geothermal energy or natural gas is interesting, So you've got to really find what you're interested in. And when you're younger, it could be a lot of things. So try them all. Try everything. Say yes to everything. If somebody calls and says, do you want to get on a helicopter and fly offshore tomorrow? Can you be there at 6 a.m? Say yes. So like, yeah, like talk to people, try things. And, there's this huge demand. Like you were saying earlier, like, I don't know if like the marketplace and the business knows what it needs right now, to satisfy what the world needs. It's like we need a lot of electricity, but at the same time, like electricians are like in high demand and nobody wants to become an electrician, or like how many electrical engineers per year are graduating from universities in your country, so it's like, there's not that meeting of like supply and demand for talent right now. It's very confusing time. Finding out what you're curious about and what you're interested in is probably more valuable than saying like, go to this training class or go to this job board. Start with what's exciting for you, because there's so many problems to solve.
What was exciting for you as a young man when you started getting into the energy space? Would you say, was it a spark for you to continue our puns?
Oh, definitely. Yeah, no, definitely. I grew up working on boats and fishing and doing ocean things like diving, fishing, boats. And so I knew I wanted to do something in the ocean, and I knew I wanted to be an engineer. So like, I just had to find like a melding of all those things. And like, literally when I looked at the college applications and I saw that there was offshore engineering, I just like checked the box, Orion. That's how I got into it. Naval architecture and offshore engineering, check. And literally that's how I got into University of California, Berkeley. Like they were looking for people that were interested in that. And so I was very fortunate. And, when I graduated, I tried working as a bridge engineer for a little while because the bridges over water, that was kind of cool. But then when I found out what people were doing offshore with some of these like mega floating facilities and the deep water projects that are in like 8,000 feet deep water, producing oil and gas there, or maybe in 10 years wind, like I was fascinated moving these giant facilities, 10,000 tons. There's a crane vessel now that can lift 20,000 tons almost. Wow. So like I was fascinated. So like I just kind of had to find a mix of what I was curious about and what I like to do, and then find out kind of a little more about those engineering disciplines. And it just slotted right in perfectly for me.
And I think then also what's interesting about what we've said here is we're like mentioning that like businesses, we're in a time of flux. The way that these things are done is not the way that they were done before. And it's sort of like younger people are the torchbearers that come in and share an energy of change that's needed in this space right now. So I guess like I would think that if you're young and you're like, I don't have anything to contribute, it's like hearing our conversation, it's like obviously there's a lot of things that are going to be changing, and the younger folks coming in are really good at that. So it's a really great time to get into the energy space, even though if you look at it from afar, maybe you're thinking, it's kind of in flux, that's a bad sign. It's actually maybe one of the best signs.
Yeah, like the newer generations of workers, like they don't like if they see a way of doing things that they think is dumb, they'll just want to do it a better way. It's like, this is dumb. I don't want to do it this way. I want to do it this way. And so like you get some really, really great innovation there. And so you just have to be able to say like, this is the goal. This is what we want to do. You guys are much better at me than innovating and finding these new ways of working. Like, go forth and do it. And like, usually if you just kind of set out the objective and the goal, people are just incredible at finding really cool ways to do things.
Yeah.
Now that's so much fun.
Let's
Yeah. The reason that solar and battery storage is like accelerating and like really penetrating the market right now is if you compare it to other like large mechanical things, like a wind turbine is large. It's just a large mechanical device. It spins around, turns a generator. There's like just not a lot of room for improvement, and they can only get so big. And like really with oil and gas, there's like, you can like drill so many wells and get the bigger facilities, but there's some limits there. But like with like microelectronics, solar panels, and batteries, there really isn't a limit. There's a technical limit. I think it's like, I don't remember. I think it's 1 kilowatt per square meter, maybe, from the sun. And like we're going to get there. And it's like really is following Moore's law, where if you look at like a solar panel from 5 years ago and like the size, cost, and output and compare it to one today, it's amazing. And like look at cost and capacity for batteries, it's the same situation. If you look at like, gosh, I don't know, just a little like lithium iron phosphate LFP battery for your camper. Yeah. Like that used to cost $1,000, and they were big and heavy, and now they cost like $300, and they're small and light. And that has happened really quickly. So I can see how, like, remember how I talked about how you need to make like all of your electricity in 8 hours and store it for the rest of the time,
right?
Like, or even longer. So like, I can see that as being possible.
It's interesting because we're at a time where I think people don't think about it like that, but there seems like there's an inflection point. If you drive a Tesla, it's like 300 to 400 miles is your range. And there's still range anxiety. That's like not quite enough for everybody. But if you double that and you get the same performance out of that same power to weight ratio battery pack, and Moore's law is about doubling every 7 years, I believe.
I don't recall the period. Yeah.
Yeah. Yep. It's not that long. It's that changes everything. If you have a car that can go 800 miles, if you can store that much power. And I didn't realize that's true as well on the solar, that there's more to gain from the actual cells as they're capturing the light.
Huge.
And that's following Moore's law as well. That's really, really cool.
Yeah. I mean, another example with the panels is like, if you were an early adopter and you put a 10 kilowatt solar array on your roof, I don't know, let's just say it's like 30 panels, maybe 35, something like that. And then today, like you were getting maybe 250 watts per panel. Mm-hmm. Today, the exact same size panel, same configuration, you could be getting twice that.
Wow.
And to replace your panels with the new ones, it makes economic sense. It's amazing. So you can go out there, you've got the same rack, you've got the same size panels. As long as your inverters are right and everything, or you may need a few more, but you can like unplug your old panels, bolt down your new panels, and you can like double your production.
Wow.
Like people are starting to realize they can do that now that they're going to want to charge their car at home, or like, charge their batteries to power something later. They're starting to realize, oh my gosh, this is like literally that doubling you were talking about. I was trying to convince my parents in San Diego to do it, because they have the early adopters and have the old panels, and like It's just remarkable how far it's come and how simple it is.
What do you think there's an inflection point where, like, how I like, for example, I know that there's lithium ion and their solid state batteries are kind of maybe coming. There's other liquid states that they're working on as well. I think that Tesla's more interested in, but do you think there's some inflection point in the future that we're going to hit that's going to cause sort of a major shift in the economy, like with battery tech?
I wouldn't even try. I wouldn't even try and guess on that one. Like if you just look at like energy density, Orion, like a gallon of diesel fuel just kicks the butt of every other kind of energy storage right now. A gallon of diesel fuel has so much energy in it compared to, like, say it weighs 6 pounds or whatever, 6 pounds of batteries, not even close. And so we've got a long ways to improve, and so, but like, if you just use a light duty car, a family car as an example, like, they're pretty darn good now. I'm not sure. We may even be past the inflection point with some things, but like, are we ever going to have an electric boat or an electric aircraft? The energy density may just never be there for that.
If you can do it with, I guess the question starts to become, are you building a bomb or are you building a battery, right? That's the trick on energy storage, is to make sure there's no runaway catalyst situation. So maybe it's tricky, because I think that gallon of diesel fuel is a bomb in a way. So maybe there's some leeway there, but I'm hopeful.
Yeah. I mean, gasoline has a lot of energy density too, and it is a bomb.
Yeah.
So yeah, it's just how you look at it. Anytime you're going to get all that energy in one spot, it's going to be dangerous if not handled properly. But just going back to your question on the inflection point, it's like when people don't even notice what kind of energy they're using is when it's succeeding. Yeah. I mean, right now, like, the barriers that are like in holding back like adoption of electric cars, if people can just fill up an electric car just like they fill up a gasoline or diesel vehicle, they don't see the difference there. It's like literally, like, I don't know, plug in for 2 minutes and you're charged.
Yeah,
great. And if there's a electric charger on every corner that there's a gas station, people won't notice that anymore. Nobody wants to be stranded. When you're stranded right now, you can get AAA to come bring you some gas if you're not a good planner. And so, like, there's a solution there. The electric solutions are starting to come out. They're not super good yet, but like AAA will bring a little trailer with batteries and they will charge your car now.
Oh, really?
So like,
okay.
Yeah, they really, not everywhere, but like a lot of places they will. So like, when you don't even notice what form of engineering you've used is kind of when you're at that point. So there's a cell phones, right? I mean, I don't know, just for fun, you got to look at the Nissan Leaf ad. Like, what if everything ran on gasoline? And the guy's got his cell phone, and like there's like a little 2-stroke engine, and it's like putting smoke out the top, and like obviously like little like micro like little devices now. None of them need to. Everything kind of just runs on batteries and electricity now.
Yeah,
so it's kind of cool. I was just thinking about that the other day, like how instead of bringing like a little battery powered generator camping with you nowadays, a lot of people just bring one of those little like battery solar things and throw up a couple of solar panels on a kickstand, and that gets to be like replacing people's generators. Then, we'll start to see an inflection point there too.
Yeah. I have one of those Jackeries that I take camping, and it's actually pretty fantastic. And you can throw up a little solar panel and charge it up if you need it. And it has a lot of energy, like just a small little suitcase, little carrying size battery.
Yeah, probably 1 kilowatt hour right there.
Mm-hmm.
But yeah, and it's just, being able to keep it topped up and filled. People worry about stuff like that.
Yeah.
So yeah, the best way is to just try it out and play around. Unfortunately, it's not free to try those things out.
I think as people, I know this from having an electric car, there is people make that shift to electric, and I would not want to go back to a cell phone that's putt-putting, and I still have like a minivan for hauling my kids around, but the electric car has a place in my life now and has for like 10 years. And I want to keep doing that because it's just a better solution. It's more optimal. and you can feel the environmental benefits of it. I mean, I know with manufacturing, it's not completely clean, but the health effects of using just electric and starting to sort of phase out some of those other energy sources when they're close to you, like gasoline, is nice.
It is, but it's never gonna like take over until it's the best solution for everyone. Like there are a lot of people that like are just happy to do something good for the environment, but that doesn't mean that the platform will succeed. Like when it works better than an internal combustion vehicle, and when people are like making those kind of choices when they go to buy a new one, that's when you know that it's successful.
Yeah.
And so, yeah, there's still a long way to go in a lot of areas. But yeah, someday we're going to be like able to cut the cord on electricity, like coming into your house, like just getting an electrical connection for like a major facility right now is very difficult. People are going to be wanting to make their own energy and electricity. So there's just a lot of cool things being done right now. Like the Costco projects I worked on, I forgot to tell you about those. We'll have to mix this in here somehow. Is like Costco literally like they're building so fast they could not get enough electricity to their facilities.
Really?
So like they just said we're going to generate our own where we can, and so they've like gone all in a few places on batteries and storage for their facilities so they can continue to build. And because they just can't do that 5-year wait to get like a 5 megawatt electricity connection.
Yeah.
And so they're going for it. So like you can imagine a big giant Costco warehouse, perfect place to put the solar panels up and put the battery storage in the back, and
yeah,
good to go.
They have a lot of roof space.
When it gets to be like that, where you're not even connected to the grid anymore, then you're winning.
I've also, and I don't remember where this came from, so maybe I'm spreading rumors, but I believe they're working on changing the regulations for what constitutes who can build power plants, because a lot of these data centers are drawing so much out of the city grids that maybe Microsoft wants to be able to build a nuclear reactor right next to their giant data center and generate their own power for that, which would be a really great solution. So you're starting to see going from a single massive controlled system to a decentralized system where effectively we all have mitochondria in our body. We as organically have come up with that model. And I think that's where we'll probably end up on a civilization-wide scale as well.
Yeah, a lot of distributed stuff. One thing we also didn't talk about yet is the fact that like to do all these things we're talking about, we need a lot of materials.
Yeah.
There's so many companies right now that are emerging, and they have materials in their name, that whether they're like recycling old materials for repurposing, for like batteries, or just coming up with new materials for magnets or motors or electrical components, like that is a huge area. And, for people also looking to like transition out of one career field into another one or start something new, like materials mining, processing and deployment is exploding right now. Like it is just anybody that's interested in that will be able to find a place.
Tell us about that space. I want to hear more about, because it's not a space that I've really dipped my toe into. So when you talk about materials manufacturing, there's like academic research going into like what kind of materials can be used. And then there's the actual like mining for rare earths and things like that. Maybe can you break that down for us a little bit?
Sure. Well, I mean, the simplest one is just copper and iron.
Yeah.
Right. Like, of course, like we just need so much more copper than anybody can mine and make right now. Getting the ore out of the ground is kind of the mining part. The processing part is getting it into copper that you can put into wires and cabling. So like, that's kind of when I mean processing, that's it. And so like, those are the really simple ones. But like, if you look into like, there's a lot of talk lately about critical minerals and rare earth elements.
Yeah.
And, they're some of those, they're not actually rare. Like lithium is like not rare. It's everywhere. But like getting it into a form that you can use in a battery is difficult. It takes a lot of processing. So like, those areas are where they're needing to draw in more talent right now, is getting so like the different materials that we're talking about are all over the place, but like a lot of them have to do with like microprocessing motors. Instead of driving a crankshaft with gasoline, like everybody wants to do it with motors now, but like the magnets and the components of a motor need a lot of these elements. So that's kind of like an example.
And then why is it so difficult, I guess, to refine these elements? Like, what is tough about, are we talking about lithium or like other things like beryllium or just random
cobalt,
pick
manganese,
stuff off the periodic
lithium.
table here?
Yeah, like you should just search
Molybdenum.
critical minerals. I did it the other day when I was giving a presentation about it. Which ones are found in Alaska? Like everyone on the list is found in Alaska. So
Alaska should have a boom around those.
It's got a lot of good materials up here. So like yes, they have to be very pure, and getting them to like a pure state that you can use in something is just requires a lot of processing. And like some of the older ways of making like lithium carbonate or lithium hydroxide, or a lot of, let's just not even use lithium. A lot of the mineral processing like uses like an acid roasting step, and you end up with a huge waste product at the end of that. So like when people talk about, refining all these rare earths and everything is so dirty, there are dirty ways to do it. And there's there are a few like much cleaner ways that have been invented recently. And like, really, we need to pivot to those. Like, but when people talk about dirty rare earth processing, it's because like, acid roasting and all these byproducts, like, please don't do it that way if you can help it.
So really it's like, take a shovel, just for me, because I'm a simpleton about everything. You're saying like you throw a bunch of acid into a vat in a way, or heat it up to high temperature along with a bunch of dirt. And then out the other side comes, there's some separation that might go on. And then you have all this sort of like acid laced dirt essentially as a byproduct. That you then
I think as you're like simplest level, that's pretty much what happens. Yeah. Okay. Right. So like you've got this ore and it has a lot of different things in it. It's a crushed rock that you crushed it up. Yeah. Right. And you want to like get the ions out that you need. So like the best way to break something down to a bunch of ions is just drop it in acid.
Yeah.
Right. And then all the ions are released and floating around in an acid solution. And then you like stuck out the ions that you need. Right. And then you end up with like the waste product afterwards. So there are much better ways to get what you need out of a solution.
And the better ways are more expensive. Is that why? And because the refineries aren't usually, at least, I mean, speaking from the US's side, but like, I don't hear a lot of talk about those I guess maybe that's a new emergent field that we're just starting to see pop up. I mean,
Tesla's way of getting useful lithium out of the ore is really awesome. It uses a pressure leaching, and they've talked about this publicly, so it's not like proprietary, but they use a better way to release the lithium, and so more people should do that. And is it more expensive? That's a really good question. It's like when you factor in the like cleanup of the byproducts, you got to compare on an equal footing. But yeah, that's one, like direct lithium extraction is kind of cool. I mean, like for years, people have just been using like activated carbon. It just kind of looks like black granules of coal, but it's activated carbon, and you can absorb things into that and then you can get them back out later. But there's many like more high tech media now where you can absorb the things that you need, and then you can like wash them out of your media to use. So that is a really cool field right now to get into. Yep.
And so these rare earths, like where's the science of those new techniques getting developed? Is it all over? Like
it is all over. It's smart chemical engineers that are all over the place, right? Very Industrial engineers, chemical and mechanical, that are coming in, and chemists that are inventing it from, the science research part, goes research, development, pilot kind of scale kind of thing.
So a rare earth sort of race, or maybe there's a Moore's law for refining rare earth sort of minerals into useful product without the hazardous byproducts, is hopefully following that 7-year doubling trend as well.
There are a lot of ways to do it better, Orion. And
Yeah.
that's where people should focus their energy and curiosity and attention, right?
And I
Like,
think,
I mean, we're talking about projects and engineers now, and yeah, there's a big problem. There's a big prize if it can be solved, and like smart people should work on it.
I think communities are a little afraid that see that it doesn't, a lot of people don't want a processing facility in their neighborhood because it was so dirty for I guess all of human history until recently that we've been able to do these things better. So it's good that we're getting the word out a little bit that these technologies are coming up and they are becoming economically competitive, particularly when you factor in the total cost of remediation.
Exactly.
Like in Oregon, we have these old mining we have lakes that just are filled with awful
tailings. Yep.
Yeah, tailings. And the plan that I think everybody does in that situation is just to not disturb it. But really, we've sort of socialized the law. Those companies are all gone. They don't exist. So it's a new generation. It's, the kids of Oregon are going to have to solve that problem. But the economic cost of that was never modeled in the 1840s or whatever, when they were like doing their stuff. So I do think I think that the cost of environmental cleanup can really factor in a lot of times, or like you just don't want to socialize those losses when there's a better option. Yeah.
I know exactly what you mean. Yep.
Yeah.
I'm 100% behind that one.
Awesome. Well, was there any other little things from that presentation? You said you just went through Rare Earth's presentation. Was there an upshot to your presentation? Were you making a case for doing a big project, or what was the?
Oh yeah, absolutely. I'm sure if you read the news now, you know that we've outsourced this kind of work to other countries. There are a lot of things that we use that we aren't like processing and refining ourselves. And like we're exposed, if you were to like just throw down a big curtain at the Pacific and a big curtain at the Atlantic, we would have trouble like building what we need. And so critical minerals, rare earths, and processing and making things here in the US is like a great idea. And we're smart. We've got a lot of good people that can do it. We've got people that want to do it. And like, we just need the like drive to do it ourselves. Like it's a little bit of a dirty job. And so like, we should like want to do some dirty jobs like this. It's going to be good for our country and good for our kids and like careers for people.
Yeah. I think Alaska will be a good place to potentially pull some of those projects off too. I hope that happens. I
think so too. Well, we've got so much coastline in Alaska. A lot of these things you need a coastline for. And we have in Alaska 2 times the coastline of the whole of the rest of the United States.
Yeah.
So a lot of opportunity there.
Well, the future is going to be very cool. And I really appreciate you taking the time to come on here. On the video, you can see I have this giant beam of light that has been hitting my face. I think it's sort of like a sign that solar power and renewables are the future, and perhaps solar in general, if you're wondering what to go into. But thank you, James, for coming on. If people want to get in touch with you or want to connect with you, do you have a LinkedIn? Is there a good way to connect with you that way?
Oh, thanks for asking, Ryan. I do. I really like talking to people in other industries and just bouncing ideas. I'd love to hear from other folks. I'm really easy to find on LinkedIn. There aren't a lot of James Wisemans on there. You'll be able to find me right away. I actually do look like my picture on there too, which, kind of sometimes rare. But yeah, I'd love to hear from folks. Please connect, and if we get a chance to meet in person, even better.
Fantastic. Well, James, thank you so much for coming on the podcast. I learned so much today about leadership, energy, people, projects, lithium, geothermal, fracking. It's been a great conversation, and I really appreciate your time today. It's great to see you. Thank you so much for coming on.
Thank you, Orion. I really appreciate being here.
Thanks for listening to the Major Project Podcast. Be sure to follow us wherever you get your podcasts and learn more at themajorprojectpodcast.com. Until next time, keep building big.